So next, what we'll do is review the MATLAB interface through the desktop application. I'll walk you through some key features of MATLAB, help you get oriented to how to interact with the different elements of MATLAB. And hopefully this will give you some confidence about both how to write code, where to write code, how to pull in data, and organize your MATLAB analysis process. So the first thing we're going to do is open MATLAB, and this will differ depending on the operating system you use and your setup. But in this case, on Windows, I have a MATLAB icon on my taskbar. You may need to go to the Start menu and find MATLAB. But in either case, we're just going to open the program by selecting the icon. Now, depending on your computer and operating system and the age of your device, this may happen faster for other people, or for some, it may happen faster for some than for me in this case. So right now MATLAB is loading, and one of the reasons why it takes quite a while to load on this computer is that I have many different components within MATLAB installed on my laptop. So I believe it's also trying to load those as well. So in general, as we now start to see the MATLAB interface, what you'll find is that MATLAB looks quite different than other programs that you might be accustomed to, like Word or Excel or anything in that the sort of Microsoft set of programs. Okay, so now we are within MATLAB. And one thing you might notice when you open your version of MATLAB is that the layout might be slightly different. So there are generally 4 or 5 elements that you would see in your layout. And if we go to the top ribbon here, so where your icons are located, you'll see a layout option. So we can select that. There's a default layout. So I'll actually just change to that. So this might be something similar to what you see. And the default layout, I think, is helpful just because it highlights 4 of the key things you might see in your version of MATLAB. Okay. So for simplicity, what I'm going to do is go to Layout, 3 column. I'm going to close this middle panel with the X here. So this is the editor or live editor. And now I have a current folder, command window, and workspace. So what are each of these windows or panels? So the command window is where 2 things happen. One, you can input commands to MATLAB. In other words, you can ask MATLAB to execute some code. And then 2, you can see the outcome or the output of your code in some cases. So let's say that I want to create what we're going to call a variable, and I'm going to create a variable height. So apparently I like to use height as an example. And we'll do this in inches. So we'll say 68, okay? So what I just typed in the command window tells MATLAB to create a new variable called height, set that variable equal to a value of 68. Now, if I press enter, you see a couple of things that happen. One, height equals 68 is returned in the command window, so I can see what I typed in for my command. And then 2, you see a change in your workspace. Okay. So understanding how information flows within MATLAB is one of the, I think, most important features and most important things that you need to do to learn how to be an effective programmer. So when I type height equals 68, MATLAB will create this variable height, and that variable is going to be stored in what we call the workspace. Okay. So you can think of the workspace as a container that holds all of the variables that are currently available to you within MATLAB. So the workspace window here tells you the names of any variables that exist, and then different pieces of information depending on your setup. So in this case, I know that the value of height is 68, and I know how much space this variable takes up on my hard drive, so 8 bytes. So it's really tiny. Now, I could ask MATLAB to display more information about the variables in my workspace. To do that, I would right-click over here in the workspace and then select any number of these features. So for instance, if I have a long list of numbers, I might want to see the mean or the range. Um, I might want to know, the size of a data set, so how many rows and columns and so on. So just again, beware that some of these things may look different if you're looking at different people's version of MATLAB, depending on what their preferences are. Okay, so talked about the command window, one place where you can input commands, you can do what we call functions or run scripts. Then once those commands are executed and you create variables, those variables are generally in this, what we call base workspace. So later on in the course, we'll talk about the fact that MATLAB has you could have many different workspaces depending on the type of code you're running. And one of the skills that you'll want to develop as you're debugging your code is understanding in which workspace you're currently working, or in which workspace you might find certain variables. All right. So the third window here that is really important is your current folder. So there are kind of two elements to this current folder that you should be aware of. So first, you want to know where this folder lives on your computer. And that's actually shown right above here in this bar. Right? So I can see that here I have on my C drive, there's a folder called users, my username. In there I have a documents folder, a subfolder called USC, another folder called projects, and then this bipedal walker. So this is some code that I've been working on recently. But let's say that I want to change this folder to a folder that we would use in class. So what I can do is click this button. So if I hover over it, it's going to ask or provide this option to browse for folder. So I'll select browse for folder. Now I can choose any folder on my computer. In this case, I'll go USC teaching BKN 553. I'll go to this year's course. And actually, I'm going to create a new folder called MATLAB code. Right? And then select folder. So you see, I just created a folder called MATLAB code. This is just something that I would use to organize the code that we use for class. And right now, this folder is empty, right? There's no code that we've been using. So the reason why it's really important to understand where your current folder, the reason why it's important to understand the current folder where you're working and its contents is that ultimately we're using MATLAB for data analysis. And so when you write commands to, let's say, load a data set, you need to understand where that data is located and make sure that you tell your code that location appropriately. And so we'll get into, again, later on, different ways that you might do that. Okay. So the next window that is really useful in MATLAB is what we call the editor. Okay. And so to open the editor, I'm going to select this option or this icon called New Script. And now the editor has opened in this sort of middle window. So when I'm coding, I'm usually working on a laptop, and I don't like to have 4 windows. It's quite crowded and it's hard to see things. So what I will often do is what's called undock this window. Okay. So to undock the window, I can just press down, undock, and now you can see it's a much bigger version of the editor, and now I can read whatever code I'm writing. So when we talk about programming and code, really what we're doing is just writing a text file. So you could write all your code in something like Notepad and then save it in the appropriate format and run it in MATLAB. But one of the reasons why we use editors in MATLAB and other languages is that these editors have what we might refer to as smart features that really help you write your code more efficiently. Okay. So just like we did in the command window, I could do, height equals 68. And I could save, this is again just a text file. I can save it. I'm going to say, call this, height, basic underscore height. So when you're working in the editor and you save these text files, we'll refer to them as scripts from now on. Your scripts are saved in a MATLAB format called an M file. Okay, so when we talk about M files, all we're saying is that you have a text file that you've saved with the extension or the end of the name as .m. So you don't need to type .m. That happens automatically when you save the file in the editor. So you'll see now in this tab that now I've changed the file name to basic height. If I leave my cursor here, you see and you read through the path, you can see that this file is saved in my MATLAB code folder. Okay. So now that I have my first script here, I can run this code. And so instead of just, if I press enter, right, that doesn't run my code, it just moves to the next line. So what I'll do in this case is press run. Okay. So I press run, and if you did that, you see nothing happens. Okay. So in the background, what MATLAB did was in the command window, essentially, type basic underscore height, which is the name of the script, and then run the script, and then we should see the output in the command window. So let's now go back to the command window. Okay. So now we can see exactly what I just said. So when we press run, MATLAB just essentially dropped the name of this script into the command window, pressed enter for us, and we see height equals 68, just like we did early on. So, and actually just to sort of close the loop here, I'm going to type clear. That's going to get rid of everything in my workspace. I'm going to type CLC, which stands for clear console. That's going to clear everything in the command window. And so just to show you again another way that we can run this script. So we can now see in our current folder that we have this file, basic height. Because it's in my current folder, I can type basic underscore height in the command window. And when I press enter, that's going to tell MATLAB to load this script and run it. So press enter. And so now that we've run this script, we can see that the variable height now exists in our workspace. So when we talk about programming, this is essentially what you'll be doing. You'll be writing lines of code in a text file, calling that text file in one way or another, and creating a set of variables. So these variables will be things, features that you extract from, let's say, a data set that we might record in the lab. So one additional thing that I want to review today is how do we actually get data into MATLAB? Okay. So there are many different ways that we can load data. I'm just going to show a very simple example, loading some EMG data and doing some very, very basic data visualization. So I'm going to go back to my BKN 2022 folder. So here I can just select this here. I have another folder called data. And in this folder, I've stored a MATLAB file called EMG data. So when you store data in whatever program you use to collect it, there are many different file formats that that data might be stored as. Similarly, in MATLAB, if you import data and you save it, you can save it in many different file formats. So one format that's quite common, that we quite commonly use, is what's called a mat file. Okay, so again, that's just the extension, the end of the file name here. So again, I'm going to clear my workspace, clear my console so I can start fresh. And when I'm dealing with the mat file, I can do a couple things. I can just drag the file into the command window, or I can load it, generally through a script. So what I'm going to do is mostly work in the command window and then transfer that code to a script. So I'm going to type load emg underscore data. So now this is the first function that we've used, load. So when a function is basically a set of code that has an input and an output. So when I call this function load, I use parentheses to specify the input. And in this case, the input is the name of my data file. So press enter. Oh, I think I need to do single quotes. Sorry. So when we type load, we use single quotes to specify the name of the file that we're loading. And now you can see that this file, EMG data, has created several variables in my workspace. So you don't really need to worry about all these variables. The key thing here is that I have a variable called data. Now, when you load data sets from other sources, the variables might have different names. So don't worry about the names here. But what I want to just sort of review here is that my variable data has this size. So most of the data sets that we use, you can think about as spreadsheets. Okay? So a spreadsheet has some number of rows and some number of columns. And in this case, when we're dealing with what we're going to call a matrix, here we have 92,702 rows and 3 columns. So just hopefully from seeing these numbers, you can recognize that this isn't a data set that you would actually want to view as a spreadsheet. Right? There's no way that you can sort of visually process 92,000 individual values. Well, 92,000 times 3. Okay. So what we're going to do is to use plots or data visualization as a way to understand what's in this data set. So first, just to help you appreciate that this is almost exactly like an Excel file, I'm going to double click this variable data. It's going to open my variables window. If I undock this window, right, I can see that I have a spreadsheet. I have many different values, thousands of values in each column. So these are actually 3 different measurements that we made during an experiment. It's not critical to know what they are right now. So now I'm going to close this window. So the next thing I'm going to do is actually make a figure. Right? So plot is one of the most common functions you'll use in MATLAB. And here you need to tell MATLAB what data you want to visualize. So in this case, I'm going to plot data. And I only care about the first column. So to get the first column in a matrix, I use open parentheses, colon, comma, 1. So the way to think about this is that you're telling MATLAB for the variable data, give me all of the values in the first column. Close parentheses. So when I press enter, I see that a figure pops up, and this is EMG data from, I believe, the biceps. So in this task, you can see that each burst of this, when the signal is sort of bursting, that's when the muscle is active, and then eventually it goes back down to baseline or values near zero when the muscle is at rest. And each of these long sets of activity correspond to sets of muscle contractions where the person was basically holding a contraction or performing a contraction that was as large as possible. So in general, when we're making figures, we really want to have meaningful numbers on the X and Y axes. We might label this, we want to label our X axis using this function called X label. And here, this is sample number. And our Y label is going to be EMG. And I believe this is in, let me pull this up. I don't know what the gain was. Let's imagine that it's millivolts. All right. So now I've added, X label and the Y label so that when you display this figure to someone, they have some idea of what the numbers mean on each axis. Okay. So that's just a very basic example of data visualization. So I've now used, 4 different commands in the command window. And in general, this is not how you would really be programming, right? I haven't saved this anywhere. If I need to do it again, I don't really have this. I have to type everything over from scratch. All right, so what I'm going to do is actually copy these 4 lines of code, create a new script, paste this code, and I'm going to go to the top, press enter, do something new here. So I'm going to add what we call a comment. So this is text that is not actually code. I'm just going to say plot or load and plot EMG data. I'm going to save this script. Plot data. And one thing that you'll notice is that I'm trying to use file names for my scripts that are meaningful, so I know what that file does. And now that I've saved it, I'm going to hover over here, close this figure, press run. And now MATLAB executes all the commands that I wrote in this script. So just in general, so what we've done now is we've reviewed the MATLAB interface, written some very basic code in the command window, and now created a script that automatically loads data, plots the data, and adds some label to our axes. So this is a general version of what you will be doing throughout the course here, where the complications will occur when we have more complex data sets, and we want to start taking signals like EMG and extracting meaningful features from these signals, and maybe even saving and exporting those values. Okay, so one of the major things that you will encounter with programming is that there will be things that you don't understand how to do. And one of the reasons why we continue to use MATLAB is because MATLAB has a very excellent help installed or help function in the program. And so we're going to just sort of take a look at how the help is organized. So if I go to my main window, there's a help option on the top right, or you could press F1 on a PC. So we'll select this, and this takes you to what's referred to as MATLAB's documentation. So under category, these are all the different what we call toolboxes in MATLAB. We won't really spend time discussing that here. But most importantly, we have this search feature at the top. So let's say I don't really understand how the plot function works. So I can type this in, plot, press enter. So MATLAB then returns all of the you know, pages in the documentation that have anything about plot. We're going to select this first entry. And this takes us to the help file for the function plot. And so what this lets us know is the different ways that we can use the function. So the syntax refers to essentially the order of information. Right? So you have the name of my function, open parentheses, my inputs separated by commas, and then close my parentheses. So I can use this function in the simplest way, which is what we did with the EMG, where I just had one input. Or I could specify separate X and Y values. I could also specify many features, these what we call line specifications that determine how the data look, the color, the size, the markers, and so on. Then there's a written description of the function and the different forms of syntax that you can use with the function. And I think what's best about the help is that there are then several examples. So if I scroll down a bit in the main window, but look to the left, you'll see that there are examples of making many different kinds of plots. All right, so let's say I want to create a plot and specify the line width, marker size, and marker color. I can click on this example. It then takes me down to the part of the documentation where they do just that. And so what we can see here is that in this example, there are two variables, X and Y, that are created. And you don't need to really worry about the details of how they're created here. A new figure is opened, and then X and Y are plotted with several different features specified, right? The width of the line, the size of the marker, the outside edge, color of the marker, and the marker face color, right? And this is the figure. So one of the things that you can do is actually just copy this code. Okay, so I select it, I'm gonna right click, copy. I can go to MATLAB, I'm gonna go to my, in this case, command window, right click, paste, press enter, and you see the same figure comes up. Okay. So the point here is that the example code that's provided in MATLAB's help is actually usable code that you can copy and paste and modify for your own purposes. Right. So that's a general overview of MATLAB. You'll see that there are lots of other functions and things that you can do up here. Frankly, I rarely, if ever, use any of those buttons. There's often just no need to. The purpose is to really try to make MATLAB, the interface, more similar to things that other types of programs that people may be familiar with. But we'll mostly be using the features and sort of forms of input and navigation through the program that we just did in this example. All right, so with that, we'll wrap up this brief introduction to MATLAB.